go into this section. But then I'll move into the first steps in D3 because you mostly need this and this to do your homework too. So before we get started, any questions about homework, administrative stuff, or anything that we talked about in SVG before we talk about JavaScript? Right, so yeah, I'm using a local version of the website, but it's the same thing. I'm just like, it seems to be a little bit slow today. Also, as you might have heard, AC is down in this building, so I'm hoping it's not going to be totally hot at the end of the lecture. Okay, so recall that we talked about HTML and SVG and CSS in the last lecture. We talked about selectors and so on. But now today we'll be talking about JavaScript. And JavaScript is essentially the programming language for web applications. JavaScript is, like, we can now use JavaScript to generate HTML code dynamically, or more specifically, where we actually create these DOM elements, document object model elements. And so I talked a little bit about this. But before we get into the details here, just like a word of warning, JavaScript is kind of like this language that has changed a lot over the last, let's say, 10 or 15 years. And it went from some, like, a really weird language in some ways that had a lot of bugs to a only slightly weird language that is much more stable, much more used. But one of the artifacts of that is that if you search on the internet for solutions to JavaScript problems, you will find really bad answers on Stack Overflow, for example. So you have to be really careful. So my best advice here is to, like, if you look at answers on something like Stack Overflow, make sure that the answers are fairly recent, right? So, like, if it's an answer from 2011, just like don't even read it. If it's from 2016 or later, then it might be containing some good nuggets of advice. And again, the MDN, Mozilla Developer Network, library documentation, or documentation is kind of your best friend if you want to learn about anything. So JavaScript, why do we care about JavaScript? What did we use like 10 years ago if we wanted to create interactive web content?
Applets.
Applets, either Java applets or
Flash.
Or Flash, yes. You all remember probably the Flash games of old. And nowadays, like Java applets, it's really hard to get running on a more modern browser or computer, and Flash is also very hard, or not very hard, but still disabled by default in many browsers. So essentially, right now, JavaScript is the only like mainstream way of running web applications in the browser. It's changing a little bit. There's a new kind of like idea that is being developed. That's WebAssembly, where we can kind of like write general purpose code and then interpret that by the browser. But we aren't quite there yet. And JavaScript is kind of like the most used and the most important one on the internet. Also, notice that there is a language that's called TypeScript, which is kind of statically typed version of JavaScript, which is like on top of JavaScript. And you can compile it or transpile it into JavaScript code, and that has like several advantages. We use TypeScript in our lab for all our projects, but you still have to know JavaScript, and so we'll like simply like talk about JavaScript, and JavaScript has become much more elegant since I taught this course for the first time. Okay, so why do we need JavaScript in the first place? So what we'll do in this like part on this page here, we'll just treat JavaScript as a general purpose programming language, right? We talk about operations, such as like mathematical operations, functions, loops, and so on. This is going to be like a quick introduction, but what we really care about is the ability of JavaScript to change the content on a website. And so that's the second part of the lecture. First with D3, and then with the standard DOM API. Okay, if you've like heard about different types of programming approaches, you've heard probably about object-oriented programming or imperative procedural programming or functional programming styles. And the nice thing is that you can do all of those in JavaScript. So you basically can choose and pick what is good, and we will actually mix and match frequently between object-oriented and functional programming here. The other thing noteworthy about JavaScript is that it's a dynamically typed language, so you do not have to actually define your data types. And TypeScript kind of like makes it into a statically typed language. So it depends on what you count, what your philosophy is. But dynamically typed languages are convenient. You don't have to think a lot, but they tend to be a little bit more error prone, and they are a little harder to check for correctness with bug checking tools and so on. The other thing that's curious about JavaScript is that if we talk about object-oriented paradigms, JavaScript is actually not a class-based language. It uses prototypical inheritance. That used to be very salient to users of JavaScript, but with ECMAScript 6, the latest major release of JavaScript, there was an addition of class definitions to the syntax, but behind the scenes, this is still prototypical inheritance. This might sound like weird now, but I'll talk about this in detail later. Okay. So what you want to do for this lecture here is to open up a console or like inspect the website and then switch to the console between like these different views. And then like if you load this page, you get a lot of output. Like the console will be pretty spammed here. Interesting. That's great.
It took mine a really long time to get the content for some reason.
Yeah, it probably like I have a problem with Wi-Fi here, and I'm guessing I'm including some stuff here that it needs to load. So I'll wait and just keep talking in the meantime. So if you load this, what you'll get is a lot of output, as you'll see that appears, and then you can like hit clear console here to simply get an empty console. And then as soon as you change something in any of the code boxes, you will see the output of that particular code box. And that's what you can just hit like add a space somewhere to kind of refresh it and rerun it. Okay, kind of. So I'm clearing the console now so that we have like a blank slate here, and I'm going to refrain from reloading this too much. Okay, so very basic here, and again, I'm adding like just a space here at the end so that it reruns. We do like a couple of things here. First thing is we log something to the console. This is something that's useful, of course, for you guys to debug. Then we log, get a division, like an approximation of p, 22 divided by 7, and then we use the math library to actually get the defined version of pi. Okay, so simple enough. As any language, we have variables, and in these variables we can store values. What I'm doing here in line 3 and line 5 is that I'm defining a global variable. So I'm not using any keyword. I'm saying a is 0. And this is how I define a global variable. In this case, it's an integer, which is stored as a type number. The second case here, I'm defining a string, so b is assigned a string. Notice there's no int or string or any other type of information here. I can do an array just like this. So here I have an array of strings. Also notice that arrays in JavaScript are actually more like lists in other languages. Like if you talk about C, you don't actually have to allocate the size of an array. You can kind of like dynamically extend it as you like. I can have an array with numbers here. Like for example, I have birth years. I can also do this, which I definitely recommend you do not do. Is a mixture of data types in a single array. So I can have like two numbers, a string, and a nested array in there. So I can completely mix and match whatever I want to put into an array. There's some reasons to do that, but in practice, you probably shouldn't. We have Boolean values, lowercase, false and true values, and we can assign that to variables. And then if you want to check the type, we can use the type of operator. Type of f will give us here the result is Boolean. And type of can be used similar to a function, but you don't actually have to use brackets around type of, around the argument if you want to check the type. I can redefine any type independent of their data type. So here I did define f as a Boolean. Here I'm redefining it as a numerical value. Like, as you can probably guess, this isn't completely safe to do. So you usually shouldn't do that. But there is nothing that forces you to do that. And then I can check again the type of f, and now f has changed to be a number here. When I want to use scoped function, scoping to work with variables, I have like 3 different approaches: var, let, and const. Var is kind of the classic way. This is what has been around in JavaScript for a while. And so var is like function scoped, and I'll talk more about what this means. But basically nowadays, you don't ever have to use var. Your alternative to that is let HB36. And that is like a block scope variable. And that is kind of like consistent with what you have in other programming languages. I'll give you an example about what I mean by block scope versus function scope in a minute. And then I have consts. This is also new in ES6. I can say const nationality is Austrian. And then if I were to try this here, it would throw an error. So you see uncaught type error assignment to a constant variable. So this is cool. This is safe. But of course, as in all other programming languages, const data types are only, like, they only prohibit reassignment. They do not prohibit changing a higher level data structure. So for example, here, I'm assigning to this test array, like the array with the values 2, 3, and 4. I can output the array here, 2, 3, and 4. And of course, I can still manipulate the array here. So test2 is 9, and that just works as you would expect. And this is also consistent with how all other programming languages handle this kind of thing, or most other programming languages. Okay, so let's review like this block scope, function scope thing, because that's kind of like important to understand. So function scope means, like, here is an example that demonstrates function scope. Here I have demo function scope function, and then I define a variable var a as 2. And so var a is not visible in the context outside of the function. So if I were to try to write, like here in line 9, try to access var a, I can't have access to it, which is kind of like what you're supposed to, like how this is designed. It helps you avoid like collisions, like namespace collisions. That is like usually like a problem in JavaScript. But the thing is that here I can do something like this. If true is if true, so this is always executed. Then I assign var b to 3, and now I can log var a plus var b outside here. And so, like, what's weird about this compared to what you usually know from a programming language? Yes.
You wouldn't have been able to use var b outside.
Exactly. So most programming languages use block scope, right? So var b here would only be accessible because it's been defined within that block, would only be accessible within that block. But in JavaScript, there's only for variables with that are defined by var, there's only function scope. So I can actually use var a and var b, and it's perfectly legal to do that. And that's kind of been the source of confusion for people. And instead, like, to kind of remedy this and to kind of make this more consistent and like make this behavior safer, and to also avoid name clashes, the let definition was introduced. And so let is kind of like exactly the same, but here the difference is that it has true block scope. So let a is 2, let b within that block, the if block here is 3. I cannot log that. So if I were to uncomment this line here, then it will tell me uncaught reference error, let b isn't defined. And then global scope, this is kind of like a really, really bad thing. If you like write a function and then define a variable like this without any of the keywords, what you've just done is define a global variable. And 99% of the time, this is a mistake, right? You didn't want to do that. You just forgot to add your let or your var or your const here. So you can actually, within the function, define a global variable like this without any keywords. So just be mindful that you shouldn't do that. So you can actually access the global variable global A here that I have defined within the function. So again, a general like programming style or programming rule is to kind of like minimize the use of global variables and kind of define any variables as narrowly as you can, so that you don't have any kind of conflict with namespace and so on. Okay, any questions about scope? Yes.
Is there a way to check if we're accidentally creating global variables?
Yes, you can look at the window object in your browser, and then I'll get to this later. But essentially, you can kind of like, the whole DOM is one big variable, and you can look through the window object for everything that is defined with the web inspector. So you can click on like properties here, and then look at exactly what. Well, I have to select something to see properties, but I can do like console.log window. And so here I have the whole window variable with everything that's defined in global scope. So you see like on blur, like lots of events, but there might be like some like screen X, screen left, and so on. All of this is defined as part of the window variable. And if you create a global variable in here, then it will show up here.
So you have to dig through all of that to find it.
What's that?
Do you have to dig through all of that?
Yes. It's not very pretty. Do you know a better way of checking whether you define the global variables? Probably a linter is probably a best bet, like an ID.
To do this, and you could try. Like if you're in console, you could just try typing the variable name, but to list all of them, you have to go.
Yes. So yeah, like in practice, a good IDE will help you avoid these problems. Okay, I have operators. Like in any other programming languages, I have like classical mathematical operators. I have like I can do this sum plus equals 1. So this takes this value of sum and adds this term to it. You've seen all of this. I can do sum plus plus, sum minus minus. I can do divisions. I can do the modulo operator. I can do like the type of operator, as I mentioned before. I can here, yeah, basically I can store the result of an operator like this. So here in this case we get the number printed. I can do string concatenation. So I will occasionally do this when I have compound strings, like 2+ words. This is similar to Java or Python. So that you can create longer strings. If you, for example, do console log, you can use either this if you want to add text to a variable, or you can just use commas to separate individual statements and variables in your console.log. And so I'm kind of mixing between those two in the code below. One thing that is kind of common in JavaScript is that you have to parse a lot between different data types. Very often you get something as a string. And so the one way to do this is with the parseInt operator. So here I'm calling parseInt on a string, the 13, and that will result in an integer of type 13, as you can see here. I can do parseFloat with a float number here. That would also work just as we would expect here. I can convert a float to int, and what you would expect is happens. I essentially make 17.5 to 17. Like this isn't rounding, right? This is just like casting. So 17.9 would also be converted to 17. I can do this shorthand operator, which basically tells JavaScript, this plus here, make this into a number and pick float or integer depending on what the data type is. And that's an operation that we see quite frequently, and that's kind of like a shorthand, and that's usually what we use if we need to parse scripts. Okay. Then arrays are like, well, we can talk a little bit about data structures. There's two major data structures, or three major, well, let's say two major data structures in JavaScript: arrays and objects, which are also sets or hash sets. So arrays are simply declared with brackets, as in any other language. I can have an empty array. I can access them by index, as we know it from any other programming language. But this is something that you can do, but shouldn't do. So that I mentioned this before. You can have these multi-type arrays, and if you actually output these multi-type arrays, then you will see that this just works this and true. is from the same array. I just access the second and the fourth element here at index 1 and 3, and I can simply output that. I can access the length of an array by the length property here. So I have my multi-type array.length, and I can also nest arrays. So here we have a nested array where we have like 3 numerical arrays nested within an outer array, and I can access them with like nested indexes. So here I'm accessing the array at index 1, element at index 0. So this is this here. I can extend arrays with the push operator. As I said before, you don't have to worry about allocating memory or anything like that. This is all done for you. If you push, this also returns the new length. And then the pop operator simply like retrieves and removes the last element of the array. I can also find the index of an entry. So for example, here I have an index of operator on my array. So I can say index of 21 will result in this position variable, and I can then do whatever I want with it. So sorting is kind of like an interesting thing in JavaScript because it's a little different from other programming languages. What would you expect if I sort this array? What would be the order here?
3, 4. Oh, it does it like
3, 4, 12, 15, 21 would be the natural way to think about it. However, this is JavaScript. The actual output here is going to be sorted as strings, right? This is like a lexicographic or alphanumerical comparison. So you will have like 12, 15, 21, 3, and 4 because it simply looks at the first digit, right? And so that's not usually what you want if you have a numerical array, but this is just how JavaScript does it. The way around this is to tell JavaScript explicitly how you want this to be sorted. And one way, or like the basically only way to do this is to specify like a comparison function in JavaScript. And this is something that you also do in other programming languages, but you usually don't have to do it for just integer arrays, right? But here you have a function, compare numbers, a, b. I'm simply returning a minus b, which essentially gives us like a Boolean truth value if a is larger than b, and a false value if b is larger than a, and 0 also false if a is equal to b. And now what I need to do, and this is the first time we see some kind of functional aspect of JavaScript, is I pass in compare numbers, the function here as a parameter to this other function. So I'm basically saying numArray.sort and use this function to make a decision whether two elements are like in which order two elements are. And then it replies this to all of the elements in that array, and you get it actually properly sorted as numbers. Here is like a shorter version of this. Anybody know what's going on here?
it's a lambda.
Yes, so we have a lambda expression or an anonymous function here, and I'll talk more about this later. But basically what you're saying is define a function with two parameters, a and b, that I don't care to name because I'm going to use it only once. And the function implementation is that. So all of this in like 6 characters, and you have defined a function that can be used later. And we will be using this a lot. Like a lot of D3 code looks exactly like this. And again, this might be something that is a little bit hard to wrap your head around it. I'll circle back to it when I talk about functions a little bit later. Any questions so far? Yes?
I've seen in JavaScript, like sometimes people will save a function into a variable.
Yes.
Is that like scope? Like is that in global scope right now?
Here it would be in global scope, yes. Like these examples, I'm actually doing like a lot of ugly things because I don't want to define a function scope or a function or block for every expression I do. So like my namespace here is actually pretty ugly. But yes, you can define, I'll talk later about this, but you can say let function name is function definition, and you can store it as a variable. There are some small differences between how you define those functions, but that shouldn't usually bother you. But I'll talk more about it later. Yes?
So in these examples, outside of the block, we define bar or let. Is that assigned to the global environment?
Yes.
And then if that's the case, can you just do, instead of defining bar or let, can you just define the word without saying bar or let?
You could. I'm still using var and let here just because like you are not usually going to write JavaScript in the global like on your main script file, right? You're going to create a class or a function where you do most of your stuff, and so that's not going to be a problem. So you'll basically have like one entry point or two entry points into your program that is some kind of like global object, and then you say object dot whatever you want to do, and so then you kind of like if you use let and var properly, you're actually not polluting anybody's namespace. Here in these examples, it's actually pointless for me to say let and var, but I'm still doing it just because if you want to copy any of the code, this is the right way to do it. And I didn't want to like add overhead to all of these examples to avoid polluting the namespace. Okay, so objects are basically like objects are really kind of like a multi-purpose thing. In JavaScript. So they are objects as you know it from other programming languages, but they are also built-in dictionaries, hash maps, or associated arrays, however you want to call them. And so that's like an efficient data structure. This here is a way of defining an object. So here I have let object be key 1 and key 2. And then I can access the values of my object with the familiar dot notation. I can say object dot key1, right? And this is fine. This is the way you should do it. What you also can do is this here. So you can specify key2 as a string, and that is sometimes useful. But in practice, what is the problem with this? So let's suppose I write like a lot of code. And then I want to refactor the name of key2. And I use an IDE, right? If I did it like this, my IDE is sure to catch all of the instances of key1. But if I use the string definition, your IDE has to be a lot smarter, and you have to look through like documentation strings and so on to distinguish whether this is actually the same value. So you kind of like sometimes have to resort to this for some practical purposes, but usually you should try to access an object property with the dot notation. You can also use this, this string syntax here to define these properties, and so you can also see the relationship here, right? So you can say a string key3 is 3. And that, if you've ever seen JSON, the JavaScript object notation, that looks very much like JSON. And I'll talk a little bit about JSON in just a second after I'm done with this one here. So this is where like the relationship between JSON and JavaScript comes in. I can also extend objects dynamically, like new key has never been defined. I can simply say other object.new key is dynamically added. And then here I have can access it with the dot notation again. And then here, like for objects, of course, what we like I said earlier, you shouldn't use arrays with mixed data types. You definitely should use objects with mixed data types, right? Because that's what they're really designed for. And I have like these lower level variables that actually define what is in these variables. So here I have like a person object with my name, my birth year, my nationality, and a list of countries that I've lived in. So that's absolutely fine, and this is actually like a way you use an object. Okay, so as I said, this is very related to JSON. And we will be actually using JSON a fair bit to load data for our visualization. So even in homework 2, we give you like a JSON file that you will load. And so JSON looks just like these object definitions, with the exception that there's a couple of restrictions. So you cannot do any comments in JSON. You can do comments in JavaScript just fine. And well, yeah, that's basically it. You could paste this into JavaScript and it should work. So now loading this into like with a file that you can then read as an object is a little bit more tricky, but mostly because of the security constraints of the browser. And so this here is like a code snippet that does this. And I don't want to go into the details here, but we're using like an HTTP request library. We're like checking a couple of HTTP conditions here. Then we define a callback. And so the key thing here is that we then our callback here is this read data function. And then in this data function, we say data.people. And so let me execute this. And so you can see data.people, like a data is the whole object I have in my JSON object. I have defined like a people array, and so I can access that by data.people. I can log the whole JSON object here. You can see the output, and this looks like you can see every entry here. Or I can simply retrieve anything with like indexing it and then retrieving the name. So in this final line, I'm calling this fetch JSON file function with the file path here, which is in the same directory as this code. So it's just this function, and then read data, and that's it. And so I don't really want you to understand or like really like think about exactly what each of these functions here means, but this is like a piece of code that you can use if you need to load JSON. And we'll talk more about ways to do this more efficiently later. So this uses just standard API. There's three methods that make this like a two-liner. Okay. Any questions about this?
It said XML request, not JSON request.
It's basically, I'm guessing that this is a legacy problem that like JSON, like XML was much more dominant like 15 years ago when this HTTP was created, and now it's just called XML HTTP request, but it's more generic than that now. But this is a guess. Okay, control structures. These are all super familiar with a couple of caveats. So if one is parseInt one, then I'm executing this here. So I'm in the first if. Let me run this. So you can see that I actually get into the first if. Else if syntax is this, else syntax we have here. What's different from a typical programming language here? Yes, I have 3 equal signs instead of 2, and why?
You're comparing types too.
Yes. So JavaScript was really meant to allow for quick and dirty work. And so this here would actually evaluate the true. If 1 equals 1. And so JavaScript, by doing that, if you use those 2 equal signs, is do your best to convert those types into something that you can compare, which isn't really safe behavior, right? Like if you want to write a larger program, you should really be sure what types you're working with. And so in practice, you always want to use those 3 equals. And I would even say that if you want to like do something like this, you should explicitly do a cast so that you just avoid any ambiguity of what you meant to do. So like this here would be an example. Like this here executes. Well, I'll just parse this for you. But here in this case, string and int are not the same, and like we are getting into the else branch of that if statement. We have our standard ternary operator for if clauses, like we have in all other programming languages. True equals true. If that executes to true, or if this evaluates to true, this is executed. If this evaluates to false, this is executed. We have switch statements that work on strings. So here I have let I some case, and then I switch over I, and then I come into this some case statement here, and then I basically log the switch matches. I do have to break it because, as in many other programming languages, if I did remove the break, the default would also, like the switch case would be continued, and in this case the default will also match. So you have the default here in the output. So this is also consistent with most other programming languages. For loops, we have for loops, DoWhile loops, and while loops. And so the for loop has the familiar syntax with like I define my counter, I give some condition, and then I use some increment operator for that counter here, and I can simply output that. So if I run that, I simply get my for loop is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Okay. A while loop works like similarly. I define my like here in this case and a counter at 3, And then I do while I is smaller than 100. I create this output string here, and then I increase the number of I so that I get into some kind of terminating condition. So we can see that the output of the while loop here is 3, 6, 12, 24, and so on. Then finally, I have a DoWhile loop. And so why do I want to do? Yeah.
For a switch statement, does it compare each case with the equivalence of like a double equals or a triple equals?
Good question. I don't know. But well, let's first try what it's case sensitive, right? So it I'll do the break here. So that shouldn't give default. It does give default, right? So it actually is case sensitive. And your question is, let's suppose I have 1, and then here 1. So that doesn't match. We still get the default here. And then here, it does match. So it doesn't actually coerce types for a switch station. Okay, I just was talking about the DoWhile statement. What's the difference between the DoWhile and the while statement?
You execute it once.
Exactly. I can execute it once. Like it's guaranteed to be executed before I get into the while condition here. And so this always runs, again, independent of the truth value of this. It always runs at least once and then keeps running until this condition here turns to false. Okay. Another thing that you probably might know from Java or Python is our for each functions. For each functions, like 5 years ago, this would have been the way to do it. So you actually call on an array or on some structure, data structure, you would call a for each function and then pass a function what you want to do for each element. So this is like the very JavaScripty way of doing this, and you still see this a lot. However, now with ES6, we can actually do this in a more familiar syntax, which is also like easier to read in my opinion, is for let year of years console log year. And this does what we would hope it does. Like our years array here is like these 9054, 9049, and so on. And so let's see what we get. We get for each function 1945, for off loop 1945, 49, 81, 82, exactly what we expected. So what's unique here is that usually in other languages this is in, right, not off. But in JavaScript you should use the off. There is an in, but the in means something different. The in, you can use this, like here I have my years object, and this is going to work. But what the for in does is it actually iterates over the keys of an object. So for year in years will give you, like what you would expect here is 1945, 1949, 1981. But if let's say, if this would be what I would expect, right? 1945 and so on. But if I do this here, you can actually see that it gives you 0, 1, 2, 3. So that's odd. And the reason why it does that is because these are the indices. And so I could actually access this like that, years of year. This is kind of like makes a little bit more sense if you think of it in these terms. Like here I had an array, years. Here and I have an object with A, B, and C. And if I do for property in object 1 and then log property and then access object 1 property, I get this A1, B2, C3. So like this for in iterates over the keys of the object, also just because it's like a set data structure, a hash table-like data structure, the object order isn't guaranteed. So you should never use this to iterate over an array. And in practice, you really mostly want to use the for off loop. Yeah.
Do you need to terminate your statements with semicolons? Like Like half the time you do it, the other half you don't. Like
Really, I don't do it half the time.
36.
I'm trying to do it. It's not enforced. I think it's good practice. Your linter will complain if you don't do it. I sometimes forget it. Yes, here I forgot it. It's not going to change the execution.
What do we use as a linter? Like you gave us the W3C HTML validator.
Yes.
Is there one for JavaScript?
Yes, there are. There's JS lint, JavaScript lint, and I would still recommend that you basically use your built-in linter into your IDE. Usually you do linting as part of a build process in a larger project, right? But we will not even talk about build processes in this class. Okay. Let's talk a little bit about functions. I already hinted at functions. This here at the beginning is my familiar function definition, right? I have the function keyword, my function name, and then any parameter. So then I can do like something in my function and do a conditional return here. So here I expect like a number for this number function, and if it's smaller than 10, I return the number. If it's larger than 10, I multiply it and return with itself and then return it. So if we execute this, we get for 30 what we expect, 900. From -5, we get -5. So this is fine. Now to the not so fine part. JavaScript tries to be convenient, but also makes it kind of like tricky, right? Number function with a string of 50. What's going to happen here?
Yeah, 50 times 50.
Yes, as you guessed by now, it will actually try to simply convert it for you. So if we get 2,500 here as the result, it converts the string automatically to a number if it can do so. Now, in this example here, I'm passing in a string. What would a good programming language do? It would throw a runtime error in some way, right? JavaScript simply meant, oh, you thought you want to put in not a number. So I'm kind of converting this to a number, and we'll try to do that. Not a number times not a number is not a number, so we get not a number as a result here. I can also do this. Like here, I have never defined a function with a signature that has two parameters. I put in a number and then a string. What is JavaScript going to do?
Ignore the extra ones.
It ignores the extra parameters. It's just like, oh, you probably meant this other function that you've never actually defined exactly like this, but I'll just make this fit for you. And then we can also do this with no parameters, and that will kind of like interpret it as undefined. So it's quite tricky to get like signatures correct, right? In JavaScript, you have to be very mindful of this. So no runtime errors anywhere above. And then we talked about this earlier. There's an alternative way of defining functions. This is your question from before. Here I'm actually defining a function just as a variable. I'm saying let variable function be this function definition here. And I'm using the function keyword here and like pass a parameter in, and then I use this parameter. So this works just as we would expect. We can like run it like here we return big if it's bigger than 10 and small if it's smaller. So this again. And so this is big. And we can, however, then also reassign that function without any penalty, right? I can say a variable function. Since it's a variable, I can take another function and write it on top of it. That's also a little bit tricky, but sometimes quite useful. So for example, you can override functions that the browser provides. For example, if you want to console log stuff, but you want to see it in HTML, you could override the console log function to do something else with it, right? You should still call the real console log function, but it's just a way of basically reassigning these functions. Okay, and so this will return, like this will use the new term as we expected here. Okay, and then here we have the example of anonymous functions or lambda abstractions. So here, like I did this earlier for the sorting, here I'm doing it for a map function. So this function is applied to every number in this data structure, myNumber.map. Then I have function D. Notice no function name, just the parameters. Then I do something, I return it, I close the curly brackets, I close the brackets, and this will work just fine. So here I get like my original array multiplied by 2, so 2, 4, 6, 8. So this is kind of like super common, and then in ES6, the shorthand arrow functions were introduced. And so this is exactly the same thing as before here. Like notice this like 6-character statement here is equivalent to this statement here. I'm basically doing this, like D here is my parameter, and D multiplied by 2 is my return value. So very concise. You can do something like this here. This creates a function that has a body that does nothing but return 12. So that's not particularly exciting, but it kind of is an unfamiliar syntax, right? And here you would get, for F1, you would actually get the result here as 12. Then here we can define a function that multiplies a parameter. So here I say F2 is x arrow x times 2. That is simply like a multiplication, and I can call this now as a function. F2 for 4 is 8. I can do multiple parameters. In this case, I have to put it into brackets. So here I have x and y, then an arrow function, and then I can use curly brackets if I need multi-line body of my function, and then simply do anything more complicated in here, and that will work just as well. I guess it's a little bit common to do like these more complicated behaviors with explicit functions definitions, but I think it's pretty much a wash nowadays how you would do it. Okay, does this kind of like sound okay to everybody? Yeah.
What's the 4 in the parentheses?
The 4 is the size of the array. So the print, the console log here is always a little bit smarter than just a trivial print, right? These are actually objects, so I can actually look at exactly what is this object here. So you see the 4 is blank. And so this is like, console log is super useful because you can log any DOM element and it will just print the whole object and you can inspect the whole object at runtime. Okay, so now let's talk a little bit about object-oriented JavaScript. I said it's like a multi-paradigm language here where some of the functional aspects, now let's look at some of the object-oriented aspects. So here is again something, well, that is actually, again, a little bit functional. I'm actually using a function to create something that looks like a class definition, right? I say function create object with content, and then I define a variable result in that function, and in there I define this object that has a couple of function parameters that look very much like methods that do something or store something. And so that's kind of like the way like people used to create object-oriented, or that you can basically emulate object-oriented programming here. And so this works just as you, like here I have my create object function, this is my f, and then I can use this just as like an object as I would expect, like f.get, f.twice, f.set. All of this is just well defined, and all of this works. So what I can do with this is I can also do inheritance, right? So here I have two objects, base and derived. And in this case here, I'm trying to access base.v1, which is defined, right? So base.v1 is defined, so we have 1 here. Then I'm accessing derived.v1, which is defined, which in this case is 5, and then derived.v2, which in this case is undefined. So there isn't really a v2 defined in the derived object because I haven't hooked up any inheritance here. So what I can do now is I can say object set property of derived base. Okay? And so what I'm saying here is that the prototype of my derived object is my base object. And so this is like inheritance now. And so now what happens behind the scenes, if like you are looking up in the namespace of the derived class, if you find a v2 in the derived class, you're done, you simply return that value, no matter what your like higher level parents have stored. If you do not have a v2 in that namespace, you move up one namespace to your prototype object. And if you have one there, then return it. So this is like class inheritance, basically. But in this case, on an object level, right? Not on a class level. I will actually be able here to access derived v2 via the base v2. So here 2 is what I'm accessing here. And then I can create a stack of like nested objects. So here I'm just doing object.create null. This is just the same as empty curly brackets. Then I can say object.create empty object. So I'm telling essentially here, create me an object and set this here as the prototype to that object. And then I'm doing this again and again and again. So I can nest it arbitrarily deep. Okay, so this is like how this all works behind the scenes. On top of this, we have now classes in ECMAScript 6. So this is kind of like convenient because now this looks very familiar, right? I have a base class here where I have a constructor, I pass in 2 parameters. I assign this dot first is first, this dot second is second. So these are my like object or let's say class variables. And then I define a method where I can access this dot first, this dot second, and then I can simply create that. And then I can also extend, like here, I'm essentially creating a new base class with 2, 4, multiply it, and it will give me the 8. I can do then like inheritance. I can extend the base class with the derived class, which now takes in 3 parameters in the constructor, and then I override my multiply. So in this case, if I use the derived instance with 2, 4, and 6, the multiply will actually call the overridden multiply instead of the original multiply and give me the result that I would expect in this case here, 48. So all of this is kind of like intuitive if you've seen object-oriented programming before. But again, behind the scenes, this is all works by, like this is not class-based inheritance. It's really object prototypes, how this works in the browser and behind the scenes. So one thing that you have to be a little bit cautious, and that's also unique about JavaScript, is this special variable this. So why is this a problem? So here we define an object, and I'm giving it some methods and some values. And so if I do this here, like I'm basically saying return this dot x, and this dot x is new value, right? So this is kind of like what I expect here. So if I do something like I create another object with 3, and then this is going to work just as I expect. So x will be 3, and then if I call the getter, that will give me 3. And then if I set this, then it will give me 5 afterwards, and if I retrieve x directly by its property, it will also give me 5. So everything here is exactly as I would expect it. So now I can screw it up though. I can do something here. I'm defining this object as yet another object. This still works as I kind of expected it. But now I'm reassigning the get function here to t. So basically what I want to do is, like, this is a functional programming language, right? I can store a function in a variable. Now what I wanted to do probably here is to also store the information about the object. But it's actually not the case because this is always in the context of the calling object and not in the context of the class definition or the definition that it was made in. So here, I'm actually, like, if I call t, even though like 3 here is properly defined, it's actually accessing undefined. And it's because the context of the calling object is the global object, the window object. So this is like slightly confusing, I'm sure. But essentially, this is like one thing that you have to work with. And sometimes people store explicitly the local context of this as that to get around this kind of problem. Okay, there's a couple of other things. These are more syntactic fun stuff. I really do not or cannot not talk about these 3 today. So I'll just move on to the 3 stuff and then revisit the other things here as we have time. But before I do that, any other questions about JavaScript here? Okay. So what's D3? D3 is a JavaScript library for manipulating DOM object. And D3 was developed by Mike Bostock, Vadim Ogievsky, and Jeff Hare. And like my outline here is based on partially by a talk, on a talk that Vadim once gave where I was in the audience. It was a funny talk, so but I'm like not quite as funny as him. So anyways, D3 is like actually a super popular library for data visualization. It used to be, or it still is, maybe one of the most popular libraries on GitHub. And what's cool about it is it really is designed for data visualization. First, it's all about binding data to the document object model. You can use D3 to manipulate pure HTML, but most commonly it is actually used to manipulate SVG for database. You should definitely, like in addition to everything that I covered here, you should definitely read Scott Murray's book. It's kind of a gentle introduction that goes into more details than I do here. And the D3 API reference here is also quite useful. And then there's a lot of online examples, especially Mike Bostock's blogs, that have like all kinds of like simple examples here where I can do something, interact with something, and it also gives you the code. These blocks always give you all the code of what exactly, like how this was implemented. So it's great because you can like have so many resources. You just have to be a little bit careful because D3 has been like updated from version D3 version 3 to version 4. There was like a major update that kind of breaks a lot of stuff, and many of the examples that you see on the internet are still D3. So if you want to see whether what you can find in an online example is compatible with what you want to do, for example, in this class, you should always check which version they use, and this is kind of the script tag that they use for version 5. Okay? Of course, D3 isn't the only DOM manipulation out there. There are other ones like jQuery or even React essentially does basically DOM manipulation for you. But D3 is specially made for data visualization. So who's worked with like any other like jQuery or something like this? A show of hands. Okay, a couple of people. So what's the great thing about jQuery? Super easy selections of elements, right? You say like $ dot something, and then you have whatever element you need. And so this is also the same thing in D3. So what do I mean by selections? Remember, like going back to CSS selectors here. So here I have like an HTML document that has a body with 2 paragraphs, and then I have script here. I've included D3 here. And here, this is my first ever line of code in this class that uses D3. D3.selectP will kind of like, not surprisingly, select a paragraph element, right? This is similar to our CSS selectors. And then this selection is stored in this paragraphs object here, and then apply this style function that D3 provides. I say paragraphs.style color steel blue. And then here I had 2 paragraphs in here. Only the first one here is colored in blue. That's because I've used select and not select all, but I'll come back to that in a second. So this is kind of like simple, but that's kind of like the simplest D3 program that you can probably write. We'll talk later about how you could do this with the standard API. I'll come back to this next week, but today I really just want to show like how you do stuff in D3. So here's a little bit more complicated example. I have now 4 paragraphs, and I want to I use like first the paragraph definition, then an ID definition, and then 2 class definitions. I run D3 select paragraph, and then style it with color, and say steel blue. So the paragraphs that match that will be in blue. Then I select the second ID, and notice that I do simply like in CSS, I say #2 for the second ID here. And then style this in teal. And then I select the other class, again with the simply period other. That's the class definition now. And then I call it this in dark orchid. And this is exactly what I get here. Again, this only returns the first match because I have like used select and not select all, and this would be the result here. So if we use select all for this, then we would actually, like here we have 4 paragraphs. If we use select all here instead of select, we get select all elements of that certain class or property. So this is usually what we want to do. You usually do something like D3 select my SVG, and then select all my rectangles. Okay, so one thing that you will notice here is that I haven't done, like what would I usually do in a programming language if I want to make 4 elements blue? I would write a for loop and say for each element apply style blue. But that's not how D3 works. It's kind of like this more declarative approach. So what you do is you try to be smart about what you select, and then you apply the style to the whole collection here. Like PS now has all the paragraphs stored in them, and it applies this rule to all of the paragraph elements. And that's why I get like 2 lines of code, and I can make all of them blue here. Okay, so here's an example that is, we can't only like modify style properties, but we can also modify any property. We can add stuff. So for example, here, I start out with my same 4 paragraphs as before. I select all paragraph, then I append a span to every paragraph, and in that span I add a text. It's a new text in span. And so like if I look at this now, I get these, like I get the original text plus the new text in span. And if I inspect this, you will see that I actually do have the span element in here, right? So I have the original element, and then I have added the span element. And so this is how I can add content elements or text to my DOM. So now the next couple of examples will be interactive. So I'll be clicking a button to see something happen, and there's like this very simple code snippet here that I'm embedding for all of them. This is like just a function or like a button that I created, and the onClick runs an execute function. So this here is a function, and so all of the following examples, they will have this execute here. So like you see, here is my execute definition, right? And so what this looks like is I have this run button here that is defined in this little snippet here that I load explicitly at the top. And then what it does, as soon as I click the button, this function is executed, right? So I can show you what is going on before I execute JavaScript. Like basically here I have these 3 gray rectangles, and what is happening after I have like executed the JavaScript. Okay, so this is like fairly simple. Okay, so now, like as I said, like in the SVG lecture, SVG is very similar to HTML. I can access elements in SVG just as I can access HTML elements. So now we'll actually do some selections on HTML elements. Okay, so what are we doing here? We have the 3 rectangles that I have created in SVG by hand. Now I say D3 select all rectangles, set them to set attribute X, which is the position, to 0. Then attribute Y to something a little bit more complicated. Then width and height, and then assign them. Okay. So now what's this little bit more complicated stuff in here? So a couple of things are interesting here. First, what I'm doing here is method chaining. Like notice that I say p.attribute something, .attribute something, .attribute something, .style something. So this is kind of like a programming style, and D3 always returns the selection again. If I run p.attribute, it also returns the selection, and I can apply the next function. Right? This makes for this very concise declarative notation. So the second piece here is this anonymous function that I use here, like function di, return I multiplied by 90 plus 5. Anybody can guess what this is doing? Yes. So I'm using an anonymous function, and the D3 library passes the first parameter is a data object that was bound to it. We'll talk about this later. The second parameter is an index of the index of my element in the selection. So if you have a collection of 4 rectangles or 3 rectangles, it's going to be 0, 1, 2 in that sequence, right? And so I'm using the I here, I'm not using the D. I still have to put in the D just because I need the order or the correct signature. I multiply it by 90 and add 50. And so what this now does is it changes all of these elements to these nice bar charts, right? So I have kind of defined them in y by multiplying it with the I by 90 here. Then I have for width, I have actually used here the shorthand arrow notation, which you will very frequently see. I multiplied this I by 150, added 100. I set the height to 20 and fill the seal blue. So this is what we get. Okay? Yes?
When you source run.js, is that implied to be a local file? Or something?
Yes. The run.js is this snippet here.
Yeah, but so when you say src equals run.js,
Yes.
because it's a local file?
It's just a source, right? It could be a remote file. I could put in a full URL here, but I'm just saying, like, no, this is the full path because it's in the same directory here. Yeah. This is just my shorthand so that I don't have to do that same function all over again. Okay, so this is cool, but now I haven't used any data so far. Now let's talk about data, and this is really like what D3 is all about. This is the magic line here. Like I do a selection, select all the rectangles, and then bind the data to it. And I'm using an array here, so I'm saying dot data 127, 61, 256. And now I can use this data. That is kind of like the data here is what is mapped into this D parameter here. And I can use this to do this data-driven styling. So here, I'm saying width D is D. And so I'm saying the width of the rectangle that you're currently looking at is supposed to be the data that it's mapped at. And so let's look at what this does. This is my before state, then I click run, and now I have a data-driven bar chart, right? So that's the thing that kind of like D3 like revolutionized. And so now I want to show you like what is going on behind the scenes. I can inspect this element here, and then I can click on, let's pick this element, and then I can search for its properties. Here's properties. And now I can actually look at my rectangle, and I can find somewhere down here, I will see my data. So underscore data equals 256. And this is what happens behind the scenes, what D3 did. It wrote this underscore data object to that rectangle DOM element. And so if you ever need to debug, are my data elements bound to the right object, you can simply look at this here, and then you will find that element here. Okay. This is kind of the most important thing for today. So everybody got that? Any questions?
If you change that property, does that change the visual?
You can change the property, or they can change it, but D3 will not work anymore. So that's kind of like a convention. You shouldn't usually access this by hand. This is more for debugging. You get it basically passed in as the first parameter here as the D. And notice also that this is really the order is important, not the name, right? It's by convention, it's always D and I, but it could be my data element or my index element name. Yes?
So when you pass in the data, you're passing in the data in order for first rectangle, second rectangle, third rectangle. That is automatically done.
Yes.
What if you just want to select like the second rectangle?
Then you have to write a more specific selector, or you can do something with D. So you could say, if D is an odd number in here, like here where I simply say with D is D, I could say if D is an odd number, then set D as with, otherwise set 5. That's something you can do. Yeah?
Why did you need to do let SVG and D3 select?
That's more of a convention. You can do directly D3 select all rectangle here. So you usually you want to be a little bit more, you could have multiple SVG elements on your page, right? And I'm selecting on a rectangle here, which you usually wouldn't do either, but yeah, I could just do like the D3 select all rect didn't work. Okay, so now some interesting cases. Now what happens in this case here if I have 4 elements 4 data elements. Here I have like an array of length 4, and I have only 3 SVG elements. So what I do here is it doesn't actually work. So I only get the 3 elements styled. I don't see anything with the 4th element here. And so we cannot, in this case, we cannot style something that doesn't exist until we do something explicitly, right? And so to do something explicitly, we have an enter function. And so we can now tell D3 for a selection, if it exists, do that, and if it doesn't exist, do that, that other thing. So here we have a select all rectangles data binding, and now we're actually selecting. Well, now we say here our selection that we made with this select all that's stored in here. We style it as we had before in blue and data-driven white with. Then we say selection.enter.append, and the enter selection. This is now referring to all of these elements where I couldn't find a match in my data from between my selection and my data array. So I have 3 objects in my selection, and I have 4 objects in my array. Selection.enter contains exactly that one extra selection. And then I say, for that one extra selection, append the rectangle and style it. And I'm using here like a distinct styling in green and with like a different color, with a different position. And so you can see now I have added this rectangle here. What happens if I click run again?
Go somewhere else.
Any opinions?
You scroll up so you
They should all be blue, and they will appear in the right side. Because at this point, they already exist, and I did that. Like this green rectangle was now part of the previous selection here, not of the other one here. Okay, so we have done this now. It doesn't look as good. What we simply could do is I could take this code here and copy it down here, and then that would work, right? I'm still showing one in green, one in blue, but just to make it clear, like here I've done everything. Like I just copied this over, pasted it here. I'm telling it for the selection and for the new stuff, do the same thing just by copying code. And obviously, every time you say copying code, you're doing something wrong. And so that's not the way you want to do that. What you want to do instead is you want to use a merge. And so here you say, I have 4 elements. I have my user 3 elements in my SVG. I say enter append rectangle. Okay, I'm retrieving the enter. Like this is only this one element here. I'm appending a rectangle to my selection, and then I'm merging this with the master selection more or less. And at this point, selection here contains all of these 4 rectangles. And then I can apply any styling that I want to them only one time. And so now this will actually work as I intended to do. So I now have like a chart where I can actually create these elements based on data, and they don't have to pre-exist in my SVG. So now what happens if I have a case like this? My SVG here is completely empty. So this you don't see anything. And the rest of the code here is the same. What's going to happen? It's going to look the same, yes. So I only have 3 elements in this case in my data object here, but otherwise this is the same. So what I've done here, I've selected something that doesn't exist, right? And that's kind of like weird to wrap your head around, but this is like the common way of doing it. You're saying, like you either have something on your page already, then you select it, or if you don't have it, you still select it, then do the enter, and then merge it into your selection, then you have all of the object. Another question, what will happen if I do like this? Like here, I've replaced my rectangle with a paragraph. The same, yes. Because I actually like, it doesn't really matter what I'm selecting on here. You still should never do this. Like Vadim in his talk said, like if you do this, I'll find you and shoot you. This is just the kind of, like, it doesn't really matter, but if you do this, you're kind of like ruining any robustness to updates, right? If you only create it once, it's fine, but this should always be matching what you're actually creating later. Okay, So we can select things that aren't there and then enter them, and then we can actually style them based on data. Now let's see what happens if we have only, in this case here, 2 data elements. If I just run this naively, I will have a leftover block here, right? And so consistent with our enter selection, there's an exit selection. And so I can do, like, take explicitly care of this. I can say, here's my styling for the update selection, and then I do selection.exit.remove. And this tells basically D3 to remove all of the elements that it doesn't need anymore. And so if I click run now, you will see that I have my 2 bars and the extra element was removed successfully. Okay? So this is kind of the summary of like what the 3 different types of selection that we have. We have like the update selection is if we have already elements and we select on them, and that's kind of like what already exists and maps to the data. Then we have elements where we have data but no elements yet in our SVG or in our DOM. That's kind of the enter selection. And then we have elements that exist in our DOM but not in our data, and that's the exit selection. So the middle here are the existing elements that you need to modify. These are the new elements that you need to modify, and then these are the leftover elements that you need to remove. Okay, so this is kind of like, we'll revisit this, but like if you get this, your life is going to be like a lot easier in this class, and this is not something that D3 is known, that this is a little bit complicated to get wrap your head around. So like if you don't immediately get this, just revisit those examples, think a little bit about it, you will get the hang of it. And then finally, just recently in version 5, there was a new way of handling selections and data introduced that kind of makes this a little bit simpler. That's the join selection here. And join is basically just smart about enter, exit, update. So it kind of like takes care of all of this for you. Here I'm doing like one selection.join rectangles, and I'm doing this here now for 4 data elements. So it will take care appropriately of that. And if I were to remove 2 data elements here and then run that, it will take care of the exit. So that's kind of like the cheating way nowadays, or the easy way. It's actually cool to do that. It is a little bit, you kind of give up a little bit of control. You can get back some control with this syntax here. So you simply say, for my join, I have my enter function, and this is what I do in my enter function. And here is my update, and this is what I do in my update function. And so I can be much more explicit about what I want to do here. And that's cool, but I'm copying code again here, right? So if I just want to do some like slightly different handling for enter and update, this might not be the way to do it. So yeah, this works just fine. And I'm actually make this one here green so that we can see the difference between update and enter. Okay, so now for the cool part, and that's actually cheap and easy. What D3 is great at is animations and transitions, and all I need to do to like run this cool animation here is one single line of code. I'm simply saying it's .transition, and now D3 takes whatever you have already and moves it to the position and the styling with like a linear interpolation. Like here's a more complicated example where I take care of enter and exit as well. So here I am creating a new element in red, then move it over, then I'm waiting for 3 seconds, and then I'm drawing the whole thing a little bit and change its color. And so how do I do this? I'm simply like saying here, here's where I handle the enter selection. So I'm starting this out with red. And at a certain position and with a certain size. Here I'm telling you how to handle the exit. I'm saying opacity 1, transition, duration 3 seconds, and then move opacity to 0, and then remove it from the DOM. So this kind of fades it out into the background. And then here I'm like merging all of this into one big selection. I'm running the transition duration of 3 seconds. Here I'm now moving everything over to the new data-driven styling. I'm setting everything to blue. I'm running another transition with a duration of 3 seconds that is delayed by 3 seconds. I'm setting this to green and then increasing the width of that. And so that's it. I have, like, that's the way that you can create these super nice transitions, and it's pretty smart about it. So the last thing for today is like drawing lines. Like here, I'm using like a path element, and I'm using the path syntax that you've used in your homework, and this does work just fine. I can run this like that, but of course that isn't like really data-driven styling here, right? And what I can do instead is I can use these like this. Like here I have a data-driven points within x and y, and then I have my line function that is d3.line, and then I tell it what is the x, what is the y. I'm doing the mapping of dx and dy to each of these points, and then I can simply say svg append pass, and then attributes d is line function of points. So this is how I would do like a line chart, and now I get this line here in a data-driven way. I can also do cool things like, in this case here, use splines without having to think about them. Because the three-line function simply, you can say, like, please use a spline function instead of just the lines, and you get that. Okay, so this was a very fast introduction into D3. We'll go over many more cases and edge cases next Tuesday, but this should set you up to be to do well in homework too. Thanks everyone. Oh yes, sorry, one more thing. If this was fast, there are labs tomorrow at 6 p.m. In L110. So we'll go over the homework, we'll go over all of this again. Also, my office hours are not now. I have another thing that's conflicting. My office hours are tomorrow.
Well,